In this lesson, we are going to learn how to differentiate the sine, the cosine, and the tan function. Here you have the three functions, and we're going to start by differentiating the sine function. When you differentiate a sine function, you get a cosine function. That is, change in y over change in x is going to be equal to the cosine of x. And when you're differentiating the cosine function, you get a negative sine function. That is, change in y over change in x is going to be equal to negative sine x. To differentiate the tan function, you have to change tan function to be in form of sine and cosine. So we know from trigonometric identities that tan x is going to be equal to the sine x divided by the cosine x. And to differentiate sine x over cosine x, we have to use the quotient rule. And quotient rule is a rule that we use to differentiate fractions. If you want to learn more about the quotient rule, you can follow the link on the description below. So to apply this quotient rule, if you want to find change in y over change in x of a fraction, you have to find the product of v multiplied by change in u over change in x. You subtract u multiplied by change in v over change in x divided by v squared. Now the v and the u is normally the numerator of your fraction, and the v is the denominator of your fraction. So in this case, our numerator is sine x. So you're going to say let u equals sine x and v equals the cosine of x. In this case, we have to find change in u due to change in x. So when you differentiate a sine, you get a cosine function. And when you differentiate the cosine, you get the negative sign. Therefore, change in v due to change in x is going to be equal to a negative sine x. From here, we are going to take these variables, we substitute them in the quotient rule formula to get the derivative of change in y over change in x of the tan function. So let us substitute them. So change in y over change in x is going to be equal to, now substituting, we have to take the v, which is cosine x, we multiply by the derivative of u, and the derivative of u is cosine x. Then we subtract, we take the u is equals to the sine of x, we multiply by the change in v due to change in x, that is the derivative of v, which is negative the sine of x. The answer you're going to get, the numerator, you divide by the denominator squared, and this is v. In our case, v is cosine x. It's going to be cosine x squared. Now from here, you just need to simplify the numerator and the denominator, and you're going to get change in y over change in x is going to be equal to cosine x multiplied by cosine x is going to give us cosine squared x. Then negative sine x multiplied by negative sine x is going to be positive sine squared x. You divide by the cosine x squared is the same as cosine squared x. From the trigonometric identities, we know very well that cosine squared x plus sine squared x is going to be equal to 1. So we can be able to substitute 1 in place of cosine squared x plus sine squared x. And therefore, our change in y over change in x will be equal to 1 divided by the cosine squared x. Using the knowledge from the reciprocals of trigonometric ratios, 1 over cosine is always equals to the secant. And therefore, we can say change in y over change in x is going to be equal to the secant squared x of our function. If you want to learn more about the reciprocals of trigonometric ratios, you can follow the link below or the link above. And therefore, we can say that whenever you're differentiating a tan function, we should always get a secant squared of that function. That is, change in tan of x over the change in x would always be equal to the secant squared x of that function. This brings us to the end of this lesson. Thank you for watching and hoping to see you next time. Thank you.